Okay, so what we're going to be talking about today is the right pyramid, okay, and the right cone. And the reason they are called right is because, and we'll draw it right over the title, but a pyramid it's called a right because the base and the height, so it's actually like over here a bit, are perpendicular. Okay, the flat part, and if you go from the flat part, if you go from the top and you drop right down, it's a nice right angle. So that's what right means. Okay, and then like our cone, right? We've got this right up here. It's not going to be over here. Okay, this would not be, that's actually a cone, but it's not a right cone. Okay, looks like Elf's hat gone sideways or something, right? So we want it to be right over, so it is perpendicular to the radius, right? And then that would be our right cone, okay? So that's all we're going to be talking about today is the right pyramid and the right cone. And you can see that there's right angle triangles inside them. And that's why we'd hit, I just wanted to touch on Pythagoras a little bit just to kind of familiarize it. You know, summers are long, so sometimes we forget all those things. So area is always measured in what kind of units? Squared. Very good. Okay. Squared units. Okay, so like centimeters squared or feet squared. And what do we say about volume? What kind of units? Yes, cubed. Okay, so that would be your meters cubed or yards cubed. Now, if we just looked at a triangle, okay, how do we find the area of a triangle? Yes. Okay, now that's what you're often going to see, base times height. And it's not really wrong, but for triangles, the height kind of has its own little name, very specific to it. Yeah, the altitude and the base. So I like 1/2 AB, and A stands for altitude, and B stands for the base. Okay, and the altitude and base will always be at right angles to each other. Okay, A and B will always be at right angles. Always, always, always. Okay, it doesn't matter how I draw the triangle. Okay, even if I drew the triangle like this, there's your base, there's your altitude. Okay, what if I drew it like this? Okay, well, this would be your base, and this would be your altitude. So it's still perpendicular to the base, but we don't count that little dotted blue line on the bottom as part of the base length. Okay? Again, I'm assuming a lot of this is review, but we're all on the same page and it makes life easier. Area of a rectangle. Okay, first one kids ever learn. What is it? Length times width, right? Or that's a very common base times height as well. So you got your L, your W, area equals LW. I should go area equals 1/2 AB for this one. Let's say A equals. Okay, so there's our right pyramid. Mine's in color. There's a sort of different shades of gray, but it's a three-dimensional object that has triangular faces and a base that is a polygon. Doesn't have to be a square. Okay, we're thinking Egyptian pyramids, right? When we think of a pyramid, but there is the hexagonal base pyramid. There's a rectangular base pyramid. There's even a circular-based pyramid. It's a cone. Okay, it's given a little bit of a different name, but the real name is a circular-based pyramid. Okay, the shape of the base determines the name. Okay, so that's why if you have a hexagonal, there's a hexagon on the bottom. If it's an octagonal-based prism, there's an octagon on the bottom. Okay, the triangular faces meet at a point called the apex. The height of the pyramid is the perpendicular distance from the apex to the center of the base. Okay, and that would be for a right pyramid. So let's call some things. We've got, that's the apex. Okay, this here, make my line a little longer. This would be our height, or what we've already called altitude. Okay, that red area would be a, what would we call a triangular face. And then the bottom, the blue part, is called our base. Okay, so there's 4 triangles, and this is probably a square that would make up all of the surface area. Remember, surface area is the material it would take to make it out of paper. That's our surface area. What it holds is our volume. Okay? So if you had a glass and you put a top on it, do you affect the surface area? Do you affect the volume? No. Okay? Because if you put a top on something, it shouldn't affect the volume, right? But it does affect your surface area because you needed more stuff to make that top go on, right? Now, there's one thing that we have to really think about, and that's how, like, we got 4 triangular faces. I get it. But how are we going to find the area of that face? We need what's called the slant height. The slant height, or slant altitude, is not, don't ever confuse it, like look at the middle one, don't confuse it with this. It often does get confused with this, but it is not the same thing. Do you see the slant height will be longer than the height of the pyramid? Okay? And the height of the pyramid is actually irrelevant for surface area, but it is very relevant for volume. Okay? So we're going to use slant height for surface area, because that's the amount of material I would use, and I'm going to use the actual height when I find the volume of it. Okay? Now, here you can see there's the regular tetrahedron prism, the right squared pyramid. Not right, regular tetrahedron. Tetrahedron is the same thing as a triangle. But the tetra comes from 4 sides. Okay? And a regular tetrahedron, all of these sides should be the same. A right square pyramid and a right pentagonal pyramid. Okay? So we can even come back, and on this one, why don't we add one more thing? Let's call this, actually, oh my, this is our slant height. Now, we want to be very careful too. So let's, if you could just draw kind of a rectangle, a 3-dimensional rectangle. It looks like a parallelogram, but you'll see when we, and then kind of up at the top, you just put a dot. You can kind of in the middle, and all we're going to do is we're just going to join our sides. Now, because it is a rectangular based, this slant height is different than this slant height, okay? So just kind of just put in, will have different slant heights for rectangular pyramid. That's just kind of a heads up, right? Because I'm hoping by just kind of pointing that out, then many of you won't get caught. Because what is the thing that I'm worried about? Oh, you'll just find one of them and then, you know, go off that and then you'll get it wrong. And then, so we're trying to be proactive instead of reactive. Okay, and I guess we can just add this, that a regular tetrahedron has 4 equal triangles. You don't really want to get it. It is a triangular base pyramid, but a tetrahedron is a special one where all the triangles are the same. Very different than maybe something like this, where all 4 triangles are not the same. That would be a triangular, a right triangular pyramid. Would not be a tetrahedron because there's not 4 equal sides. Anything that's called a hedron, like a square or a cube, perfect. It's a hexahedron. 6 identical sides, like a sugar cube, that's a hexahedron. Okay, that's what a cube, that's what its real name is. Okay, surface area of a pyramid. It is the sum of the areas of the triangular faces and the base. Okay, so no matter what, the sides will be triangles. Okay, it's the base that doesn't have to be a square every time. Could be a rectangle, could be a triangle, could be a hexagon. Now the lateral area. This is something you want to get on a study sheet, okay? Because students mix this up. When I ask for surface area, it includes the base. Lateral area, all area, excluding the base. Okay, so we want to differentiate between these two, because if I gave you a multiple choice question on your test, find the lateral area of this, I will have the answer for the surface area. Maybe that's C, and maybe A is the lateral, or the lateral, C is the surface area, and you're going to be like, oh crap, which is which? Or maybe you'll just go right to doing surface area and get that one wrong. So you'll actually do more work. You'll probably do your work correct, but you'll be answering the wrong question by giving me surface area when I ask for lateral. Okay? Now, let's just talk about surface area. Now, let's talk about the right cone. So, to draw a right cone, you kind of do a squash circle, put a little dot up top middle, and just kind of hit your 2. Okay? Now, we do need to know, cones are really easy, actually, as long as you know your R. And you're gonna need to know your S, your slant height. So basically what we have, if you took this apart, okay, you kind of have something like this. This would be the side. If you took it apart, it would look like this. And then you would have the base. And that wraps around. Now, does anybody know if this was going to wrap around the circle, what would this be? Yes, very good. This would be the circumference. Remember, this was our slant height. Okay. So surface area of this would be this is pi times r times slant height. Okay, that's how we do that. Then we're going to add the circle. Anyone remember how to find the area of the circle? Yes. Pi r squared. So that is pi r squared. So that is your surface area formula for a cone. Okay, so mine's a different color than yours, but you should see right here on your formula sheet, pi rs plus pi r squared. So you don't have to memorize it, but we're just going to be talking about these. Okay, now we've got our right cylinder. Okay, now our right cylinder, I'm just going to do a squash circle, another squash circle right below it. We're going to go like this. Okay, now we need to know our height, and we need to know our radius. That's what you need to be able to figure this out, your height and your radius. Now, if you were to take this apart, let's take it apart over here, you would have a circle, you would have your side, actually that's a little bit too large, just need to wrap around, and then you'd have your other circle. Now, to find the area of a circle, we've already talked about, this would be pi r squared. This would also be pi r squared. So far, surface area would equal pi r squared plus pi r squared is 2 pi r squared. Now this is the same h that's right there, right? That's our height. Now, what's that distance around the circle again? Circumference. Anyone remember the circumference formula? Yeah. Yes, we're going to go 2 pi r. Okay. Pi d or pi 2r, but we always put the 2 in the front in math. Okay. So it was pi 2r, but that's, we want the number in the front. So remember, to find the area of that rectangle, it's length times width, right? Well, length is the height, or 2 pi r. So then we have plus 2 pi r times height. Okay, that's where that formula comes from. Okay, now next is the right prism, and it looks like this. Just draw a box there. 1, 2, 3. Okay, and this is length, and this is width, and this is height. Okay, and I'm going to kind of draw this like see-through a little bit so you can see. Now what we have to do is we've got to get all of those sides. Now if we talk about the bottom, just the bottom, right, like that. How do you find the area of the bottom? Length times width. What is the bottom identical to? The top. So I could go length width plus length width, or 2 length width. So surface area equals 2 LW. So I've got my top and bottom. Okay, so that's top and bottom. Plus, let's do the front and back, because the front and back should be the same. So how would I find the front? Length times height. And since we have the front and the back, we're going to go to length times height. Okay, and the last thing we have is the two sides, right? So two sides. And that would be width times height times 2 plus 2 width times height. Okay. Now let's talk about the right pyramid. Now the right pyramid, let's do a, just to keep this, let's do a rectangular one. Let's really exaggerate that it's a rectangle. So when you look at it, so we've got here, here. Okay, so what we need to find the length, or the surface area, we need to know here the length and the width. And because it's a rectangle, we need to know, okay, and we're going to call this S1. Okay, and we're going to have to call this one S2 because they're not the same. Now, if that was a square, yeah, it would be. So in this case, we're even going to call it rectangular pyramid. Okay, so now let's talk about the front. Now, the front, well, how do you find the area of a triangle? Yeah? Okay, so 1/2 AB. What's our A in that front? What's our altitude? S2. So, for the front, it would be 1/2 L times S2, right? Oops, don't ask me why I did that. That's just the front. But what if I want the front and back? What should I do? I would multiply this by 2, correct? What's 2 times 1/2? 1. So to do the front and the back, surface area equals, this would just be LS2. Because it's 2 times 1/2 L times S2. So I didn't want to go and just write down. It's just L times S2. People were like, oh, what did that from? Must be magic. That's cool. I'll just memorize it. That's all right. The little 2 is for, because that's that slant height, right? Because there's 2 slant heights. So now we're going to do plus the 2 sides. So that would be plus 2 times. What would be the side? How would I find that? So I'm doing this now. How would you find that? Right. So that would be 2 times 1/2 LS1, which would go to be plus LS1. Plus the bottom. How do you find, or I guess we call it base. what would you call, how would you find that area? Length times width, so we're just going to plus length times width. Okay. Now, why don't we, you might have room at the bottom, but if this was square, so for a square pyramid, okay, so let's just we'll call this X. This would also be X, and this would be our S, right? So without me giving you the formula, what would be the actual formula for this one using those letters? Yep. Mm-hmm. That makes sense? Because it's actually, if I could back it up, this comes from, there's 4 times 1/2 SX. Right? There's 4 triangles, and they're S times X. 4 times 1/2 is 2. And then the X squared comes from X times X. This making sense? Hard to tell Monday mornings. I don't know if people are asleep or if they're actually understanding. Okay. Did you need, okay. See, that's the power of technology. This would have been a whiteboard, it would have been gone. Okay. So this right square pyramid has a slant height of, that's a weird looking 10, but it's 10 centimeters and a base side length of 8 centimeters. Okay. So, and look how nicely your diagram is already labeled. Okay. Step 1, draw a net diagram. What's a net diagram? Yes. Right. It's like, you know, when you bought boxes before, like you can buy them at Staples and they're like flat, and that's a net, right? So if you were to go buy yourself a pyramid, I don't know why, but that's not supposed to be real life, right? Who goes out and buys a pyramid? But anyway, so wouldn't it be ironic if your mom sends you to the store tomorrow to buy a pyramid? You're like, this is so weird. I never thought I'd need to have to do this. Okay, so this would be your net. Okay, and then we want to put little things here because that says those are all the same. Why? Because it is a square pyramid. Okay, so we have our base. So surface area is going to equal x squared plus 4 times 1/2 s times x, which is plus 2sx. Now, it's really important that you're writing down the formula first, okay? These are really good habits to get into. Often when I teach these, I'll give them like 3 marks each, 1 for the formula, 1 for the correct substitution, 1 for the answer. So if you just put the answer down, you get 1 out of 3, which is 33%. If you don't even have a calculator on, you can get 2 out of 3. Okay? Because you do the formula right, you do the substitution right. Now, surface area equals, and let's start using our units. We got 8 centimeters squared plus 2 times, okay, our slant height is 10 centimeters, and our x, again, is 8 centimeters, okay? So now that you guys are in high school, right, we want to get rid of time signs. Use brackets. Brackets mean multiplication. Why don't we want to use a time sign anymore? Because x comes in to a lot of questions, right? Because what if students go, hey, x times x, that's x squared. I'd be like, no, that's x cubed, right? Isn't it? Right? They're like, no, that's a time sign. I'm like, okay, I didn't know that. Okay, we're not supposed to use time signs anymore. And they're like, oh, okay. So then surface area, this would be 64 centimeters squared. Now you wouldn't have to do this step. This would be, I would do it all in one shot, put it in your calculator. But this, we're just doing in our head. 2 times 10 is 20, 20 times 8 is 160. And we'd add the two together. So surface area would be 224 centimeters squared. Okay, so you could see where I would give 4 marks for this one. Okay, I would give 1 here, this would be 2, this would be 3, and this would be 4. Okay, because I asked to draw the net. Substitution formula, substitution answer. I always call that FSA. Okay, I'll say I want FSA, formula substitution answer, right? In this case, net formula substitution answer. Okay, that's for your formula. Substitution and answer. You'll see the irony in math and physics and chem when you get higher and higher up is the answer has the least importance. The process has the greatest importance. Okay. In fact, sometimes you can just put an answer, like say if it was written response. Some written responses, like in the diploma, will be out of 10 marks. So your answer would get you 1 out of 10. Right. So, you know, yet you can get the wrong answer and get 9 out of 10 on the question. And that's even if you did your substitution wrong in number 1. Okay, so I know it sounds weird, but you can actually get the wrong answer and you'll have a check mark there and you'll be very confused. They must have screwed up. But you can never penalize someone twice. So what if they put a 4 instead of a 3, but they did all the rest of everything right and they got a different answer than you? If you mark the answer wrong and that step wrong, you've penalized them twice for that, right? So they've taken the written response off the diploma, but I still mark diploma style. So if you substitute wrong, but you do everything right, okay, I'll still give you that mark, and you'll be like, that's weird, I got the wrong answer, but I still, okay. No, because your process was right. You just put in the wrong number. I don't even know where you got 5 from. And you're going to be like, I don't know where I got the 5 either, right? Sometimes we have those days. But it's really important you're showing your process. There's always a few students that really buck the system. They're like, I don't want to, I just want to put down my answer, right? Well, you're going to find out that real life, they don't care about the answer. They want to know, like, how'd you get it? It doesn't even make sense, right? It doesn't seem logical. You're like, no, it's 28. How'd you get that? I don't know. Never mind. It's 28, right? It's kind of like if you were getting a kitchen reno done, and they're like, yeah, that'll be 48,000. Where'd that come from? Oh, don't worry about it. It's 48,000. Well, I kind of don't want to. Hey, what are you questioning my ethics? No, I would kind of like to know where it came from. Well, I don't know. Okay, I wouldn't take that guy. That guy wouldn't be doing my kitchen. Okay, I'd be like, yeah, well, we'll call you. Okay, yeah, thanks for coming out, right? But you don't want that guy. You want that guy that can show you everything itemized. And then we've got to do this. We've got to redo the electrical. We've got to take this wall down. We got it, right? We got to paint it. We got new countertops. Did you want granite? Did you want this, right? Everything itemized. That's the guy or girl that you want to pick to do that job. Okay, next, a right rectangular, okay, rectangular pyramid has a base 4 by 6 and a height of 8. Okay, so let's draw it first. So we got our base, and it says it's a 4 by 6. So 4 meters by 6 meters. And then it has a height of 8. Now, did it say slant height of 8? No. Height, right? So it actually gave us this. This is 8 meters. So underneath, that's actually the picture. We're going to draw the net now. Okay, we got 6 meters, we got 4 meters, we got this triangle, we got this triangle, we got this triangle. I'm going to move my 4 meters in here, 6 meters in there. Now, can I put these in? I can't, I don't know them, do I? But I just want you to come back to here. I want you to look at this. This is your slant height, correct? We can call that S1. What is S1? Yes. Okay, I want to actually maybe, I want to be a bit more, I want you to see what's inside there. That is a right angle triangle. In that right angle triangle, what is S1? See, my hypotenuse. What's my A? 8. What's my base? 3. Very good. Okay, so if I take this, so I'm just going to draw this quick here. Everybody can see me drawing it. And then I take this and I move it out here. Oops, moved the wrong thing. It's not so bad to move, I guess. But if I take that out there, I can call this S1. I can call this 8 meters. And my base would be 3 meters. Okay, so I'm just taking this. That is that. Now you know why we need our buddy Pythagoras, right? Okay, so just to find S1, we will go, S1 is like C, remember? And that would be the square root of A squared, which is 8 squared plus 3 squared. Okay, so S1 would equal 8.544 meters. Now, you could go to like 5 decimal places. I actually didn't in this case because I didn't write down 5. But that is S1. Now, gotta really get your 3D goggles on here. Here's my like S2. And it goes to there. Do you see that one? So if I can change I'm going to change my highlighter. Here's my colors. Let's go pink. Okay, so there's that one. So if I bring that out, okay, so this one here, if I bring it out, we would have a triangle that looked kind of like this. So that was 8 meters. That's S2. What would be my base? 2 meters. Does everybody see where we're getting the 3 meters and 2 meters from? Okay, because this is 6 all the way here. Therefore, this should have been 3. This is 4. Therefore, this is 4. Therefore, this is 2. Okay. So, let's do S2. S2 would be the square root of 8 squared plus 2 squared. So S2 would equal 8.246 meters. So now we can go to our diagram and we could say this would be, because this is S1, correct? No, I don't think I messed up. I think that's S1 because look, 3 and this is 3, correct? Oh, yeah, that's true. Okay, right, because now that it's flipped up that way, right, we got to look at my, right, so, okay, that's good. You guys are, so the slant, this was S2, right? That was the slant that came from here, correct? Is that right? Well, you might be going crazy. This just be your first, okay, that's S2. This should be S1, and this is S1. So does the 8 have anything to do with this problem anymore? No. And it's there to give you information. So this is going to be the difficult question on the quiz tomorrow, obviously, right? So I don't even mind telling you what's on the quiz tomorrow because if you go and study it and you get it right, isn't that what I want anyway? So, okay, so let's get at her. What was our, we got, so surface area equals, we've got 2 times 1/2 times, we'll do, what would be our, like say we're doing the front and back right now. I'll just write that above it. We're going to do the front and back. So that would be 1/2 times 6 meters. I'm going to call this the front and the back. It doesn't matter, right? So that'd be 6 meters times what's S2? 8.246. Plus, let's go the two sides, would be 1/2 times 4 times 4 meters times S1, right? So I'm going to put, this was S2, this will be S1, and S1 is 8.544 meters, plus the base, which is 6 meters times 4 meters. I don't know if you can see that there. 6 meters times 4 meters. Yep. You should, yeah. No, you should. Okay. So when you do all this, now this is the same, the 2 times a half. Oops. You guys didn't catch this. This should have been 2 times 1/2. Right? There's 2 of these triangles. How come you guys didn't catch that? Oh. Okay. You guys can't let me make mistakes like that because then we all learn wrong and then you all have to take grade 10 over again. Well, I wouldn't have to, but you would. It's all our. I did catch it. I did catch it. But there's like 25 of you. Someone's got to be paying attention in here. Someone must have got to bed early last night. Okay, so surface area is, you should get 107.653 meters squared, but it said to round to the nearest meter. So that is going to be 108 meters squared. Okay. Good. Okay, let's do a right cone. Okay, so we got 10 meters is the height with a radius of 4. So we just draw this. Okay, so this is supposed to be 10 meters. This is supposed to be 4 meters. Okay, so surface area equals pi r squared plus pi rs. Remember? Okay, they gave it to us right there. Can I go for it right now? Or not? I do not have s. So right now, s equals question mark. And until I have question mark, I can't proceed. So then we're going to use our buddy Pythagoras because here is our right angle triangle. So that's our hypotenuse. So s will equal the square root of a squared plus b squared, right? So 10 squared plus 4 squared. So we don't need the brackets, I guess. And somebody said it right. We got 10.7703 meters. Why am I not rounding it? Because I never round until the end. Now I'm ready to use this baby right here. So surface area equals pi. Now don't use 3.14. Use the pi button on your calculator. Okay, all of you have it. Start using it because that's 3.141592, right? It's going to be very accurate, right? It's going to be to 8 decimal places, which is way better. If you were launching something the moon and used 3.14, you would miss the moon. Okay, they literally go to 20 decimal places if they're going to launch something, okay, or any missile or anything like that. So you want to make sure. So it's pi times r is 4 meters squared plus, I'm just going below right now because I'm running out of room. So then we've got pi times 4 meters times my new slant height, which is 10.7703 meters. And that gives us 185.60943 meters squared. 185.60943. It says to the nearest meter, so that would be 186 meters squared. Okay. The lateral surface area of the square pyramid is 3,000 inches squared. The side length of the base is 50 inches. Okay, so it's the side length of the base is 50 inches. So this is 50 inches here. Determine the height of the model. So it wants this. It wants height. Okay, this is a good one to do as a class. What should we do? Yes. Okay. Be a little bit more specific. What should I start with? Okay, help us out. That would work if all those triangles were identical. Is it? Right. Because, okay, so that's good. No base. Right? So the surface area is 4 times 1/2 BS1, right? Because that's S1. Is that correct? Can I say that? Or I should say LSA. The lateral surface area should be 4 times base of the triangle. Now we're going to call this base, okay? Is that true? What is this? That's my hypotenuse, is it not, of this? Okay. See, it's the hypotenuse of the, I want you to look, it's the hypotenuse of the inner triangle, correct? But it is the altitude of the face, is it not? Okay, does everybody see that? It is the slant height of inner triangle which is the height, or let's call it altitude, of the lateral face. So we actually know what this B is, don't we? What is this B? 25. Like, what are we going to do next? Okay, well, let's talk about this triangle here. Do I know the area of just that one triangle? How? So, if I wanted to find just the area of this, that would be, area would equal 3,000 inches squared, because that's for all 4 of them, and divide it by 4. So the area of just that triangle would be 750 inches squared. Does that make sense? Now, do I know anything about that black triangle? Anything at all? The base is what? So this is 50 here. Okay. So what don't I know? Yeah, or in this case, it's the altitude, right? Which we've already said, that's going to be my slant height once I figure it out. So this equals 750 equals 1/2 times 50 inches times what we called S1, which is our altitude. Yep. No, because 750 equals 1/2 AB, that right? Like this here is 750. And 750 equals 1/2 AB. Now, if I have, I'm just going to rewrite this without the A so you can see it. 750 equals 1/2 times 50 times S1. How do you solve for S1 now? How do you get rid of that half on that right side? Multiply both sides by 2, right? And that would cancel there. Then what would we do? I want S1 by itself. Divide this by, how would I get S1 by itself? Divide by 50. So I'm going to divide this by 50. So what am I left with on the right? Just S1, which I wanted, right? So 2 times 750 divided by 50 should give us hopefully 30, right? Because that's 1,500 divided by 50 is 30. So now we know that this is 30 inches. What was the goal for us for this whole question? We need to find the height. So now we have this red triangle here. Oops. I'm just going to color it in like it's colored in there. We have now found this to be 30. What is the base of this triangle? 25. So how are we going to find the height? Yep. Sorry, we could go A is this, because this is our A. It's the same thing as C squared minus B squared. A equals the square root of 30 squared minus 25 squared. And I get A to equal. It's a good question. So 16.58, right? Is that what you got? Which is A would equal 16.6 inches. So the height of the pyramid is 16.6 inches. So that's a pretty in-depth question, okay? You're not going to fluke that baby off if you don't know what you're doing. But Do you see how when I'm marking that on a test, on a quiz, it's going to be worth 1 mark because it's a quiz. But on a test, I'm going to follow that through. And if you put the wrong thing somewhere, but you didn't lose, but you know, it's just keeping things really straight, okay? And drawing new triangles, draw little arrows for yourself like we did here, and then, you know, here we did this. And you just go through your process. You got to keep super organized, okay? So there's our assignment, 34, number 4B, 5B, and that's page 34 in your math book. You're finally going to use that baby today. What up? Yeah, you can borrow one over here, Adrian, or maybe someone has.